All right, today we're going to be talking about Venn diagrams. One thing we need to pay attention to when we're talking about a Venn diagram is recognizing how many people are in our population. So in this case, it says there are 22 children playing on the playground. We have two categories, one of which is wearing shorts and the other one is wearing pants. Now, if you notice, this is 10 and 12, and these are both mutually exclusive events. You can't wear shorts and pants at the same time. So what we run into here is a mutually exclusive event, so these will not cross over. So this is what it looks like. We can see that both of these events take place outside of one another, so what we will be having is to calculate these individually. There is no overlap. So our Venn diagram is two unique circles. It doesn't really matter where they are. We're going to also take a look and see and rewrite our population, which our population, of course, is 22. So if I'm finding the probability of pants, the people with pants are our number 12. That would be 12 out of the 22 kids that are on the playground. 12 out of 22. 12 out of 22 is going to give us a repeating decimal. This reduces to 6 out of 11. And then it's giving us the repeating decimal of 54. 54 repeating. Now, short, since these are mutually exclusive events, is going to be the complement to that. That would be the remaining 10 students. So it would be 10 minus 10 over 22. Again, since this is 6 11ths, the other one is going to be 5 11ths. And it'll also be the complement of 54, which is 45 repeated. Now our probability of pants or short, well, pants or short, that would be actually 12 over 22 plus the 10 over 22. But since these are both mutually exclusive events and they're the only two events, what we have is a certainty here, because we're going to have 22 divided by 22, which is 1. And then it says pants and shorts. Since we have mutually exclusive events, this would be 0 because you can't wear both at one time. My probability of pants and shorts would be 0. These are mutually exclusive. Next, we'll talk about Venn diagrams that are not mutually exclusive. So we are going to see some overlap here. It says in a class of 19 students, 18 have brothers, 14 have sisters, and 13 have both brother and sister. No one is an only child. So when we're calculating this, my suggestion to you would be first determine your overlap and see what we've got. So we've got an overlap of 16. You see I've already got these labeled, or 13, excuse me. You see I've already got these labeled. So we know since we have an overlap of 13, our section that is doubled up here will be our 13. And then I like to take from each subgroup and see what we have left. So if I have 13 that are overlapping, what I will do to find out the remaining sisters is I will take that away from the remaining sisters, and that will be what's out on the other side. And then I will take that amount from the brothers as well to see what falls on the outside of the brothers. When I'm done with this, what I should see is this adding up to 19 when I add all three sections. So if I have 14 sisters and 3 of those are both brother and sister, that means there's only one person that falls into this pink region here. And again, a Venn diagram, we don't know exactly if the size is going to fit, so don't concern yourself with it looking proportionate. So this would be 5 people that just have brothers. I want to double check my Venn diagram to make sure that it does add up to 19. And 5 plus 13 is 18 plus 1 is 19. So this Venn diagram is accurate. So if I want to find the probability of a brother or a sister, well, if we think about this, there are no only children. So that would be the only scenario where we don't have a brother or a sister. So in this case, it's actually 19 out of 19 which is a certainty since we have no only children. Excuse me. Now we're looking for the probability of a brother. Well, the brother involves both only a brother, the 5 that have only a brother, and the 13 that have a brother and a sister. So that would be a total of 18 out of 19. This makes up about 95%. It would be and we're going to approximate this, so it's 0.947. That would be our probability of having a brother. And then the other one would be not a brother. Well, the only person that doesn't have a brother is the one that only has a sister. This is also the complement. We could have taken the probability of a brother and just done the complement of that and subtracted that from 1, but we can also do the 1 divided by 19. 1 divided by 19, like we said, it's the complement to our other number. This is going to be just under 5%. Over 5%, excuse me, 0.0526. And that's how we use our Venn diagrams to calculate probability. And I will have the diagram for the data for number 3. We will get that in class and you will have that. And I hope that I will be able to post that data in either a sentence or in a chart over here to the left, and you will construct a Venn diagram